not able to change this base. So what I do is, in this situation, is I take the log of both sides. So I go log 8 to the 2x plus 3 equals the log of 12 to the 2x. Now what do we know about our log rules and exponents? What can I do with the exponent? Move it to the front, that's right. So I'm going to take this exponent here, move it down here, and this exponent here, and move it right there. Again, these are things that we learned and applied. Alright, this is not new to us. How we solve them is a little bit new. So I have this right now, 2x times log 8, or 2x plus 3 times log 8, and then I have 2x times the log of 12. So far so good. So all I've done is 2 steps so far. Take the log of both sides and move the exponents down. So now that I have them down, I can now work with this and solve my question. What base are these two logarithms in right now?
10.
They're in base 10 because I don't have a number there, they're in base 10, which is what your calculator works in. So we've got that also figured out. So I'm going to distribute this through the brackets. So I get 2x log 8 plus 3 log 8. Okay, 2x times log 8, 3 times log 8, equals 2x log 12. So far so good. Any questions about that? All I did was distribute. Now what I'm going to do is I'm going to put the x's so that they're on the same side of the equation. So I'm going to leave 3 log 8 here. And I'm going to get 2x log 12 minus 2x log 8. So I subtracted this guy to the other side. That's the guy I was working with. Following? What do you propose I do now? I have the x's on the same side. My objective is to solve for x, so how do I then somehow get this so that I can get an x isolated? If it was equal to 0, what would you do? Factor what?
The 2x maybe.
Yeah, absolutely. You're right. That's exactly what you do if you had 0, equal to 0, right? Well, I'm going to do the same thing. Except I'm going to leave the 2's in. Okay? I'm going to leave the 2's in, so I get 3 log 8 is equal to x. So I'm going to factor 1x out of both of these. So I take the x away from there, I'm left with 2 log 12 minus 2 log 8. Everybody see that? Anybody not see it? Not sure? Okay, I'm down to my last step now. What do you suppose I do to isolate x?
Divide by 2 log 12 to equate 2 log 8 on both sides.
Very good, Jeffrey. That's exactly what I do. So I have 3 log 8. I'm going to divide it by 2 log 12 minus 2 log 8. Let's punch that into our calculator. Brackets are necessary if there's going to be a bunch of them. I want everybody to punch this into the calculator so that you know that you got the right answer, because this is where we do make errors. If you get this far on the exam, you got 3.5 out of 4 marks. The last half a mark, usually, maybe 1 mark, is just for the solution here. What'd you get?
0.683.
One what, sorry?
0.683.
You get 0.683?
Yeah.
Campbell?
I had 7.693.
Yeah, that's what I got.
Okay, try it again on. Maybe you're right, maybe you're not, I don't know. What did you get, Campbell? 7.693. That's what you got as well? Okay, great. So, on. You're gonna need that there, right? They'll have the open brackets for you there,
Yeah.
there, and that means you have one on the outside as well here. So just check your bracket work, that might be where it comes down to. You must open a bracket down here before the 2 log. Anybody not able to get that?
Same. I have.
You got the same answer?
It's 2 log 12 minus 2 log 8. 2 log 8 plus 2 log 12.
Yeah.
Thank you.
Thanks, Campbell. Anybody else need help with that, or did you get it?
I have negative.
I got 0.69 worse 9.
2 log 12
First time.
minus 2 log 8.
Your
You have
bottom.
the 8 with 12 backwards. That's all.
Nothing. Thank you.
You gotta multiply here.
Oh,
Instead of. There. Allison? Good? Okay, anybody else? So, let's review our steps, okay? Step number 1 for us was log of both sides. Okay, so you log both sides. Step number 2 was what?
Move the exponent.
Move the exponents to the front. Step number 3 was
Multiply through the brackets.
distribute, very well said. Multiply through the brackets. Step number 4 was
Get the x's to one side.
get the x's to one side, awesome. Step 5 was
Isolate x.
isolate x, and step 6 was use your calculator to solve. Awesome. Okay? The first 2 steps are done every time. Where they will add difficulty to it is, for example, in D there. In D, they added that 2 in front. You now have to use a log law. So I'm just going to start you on that D, 6D. So when they have 2 times 6x plus 3, and you take the log of this side, don't write this down, I just want you to watch. When I take the log of, when I take the log of that side, I start with this. Okay, and I did this on Friday. Because it's multiplied here, right? What's the log law? Add. So that changes to log 2 plus log 6x add 3. Okay? My logarithmic law says that if I'm multiplying here, I change them and I add them. That's the first rule of logs.
it's x plus 2 there.
That doesn't matter. I got what I need. So the main thing is to see this. The number 1 mistake that gets made. Remember how I said this with trigonometry and nobody wanted to listen to me and still made the same mistake? Alexon, not pointing fingers. Okay? Do not multiply these 2. Do not multiply them ever. You can't multiply them because the bases are different. Alright? So that's the mistake that almost all students make right off the bat. They forget that this is a log law. Okay? Alright. One more check on this. Questions, concerns?
I just have a general question. So when it comes to 2x log 12 take away 2x log 8, how come we can't just take away 8 and 12? Like, because it has the same base.
Yeah, that's what I was wondering too.
This value is not the same.
Okay. So like everything has to be the
Yes.
same here.
These are different values altogether. Take the log of 12 and log of 8, they're completely different.
Okay.
Okay. One of the other mistakes that gets made on these questions is students don't like working with logs and they change them to values right away, which you can do, but if you start changing these to decimals right away, you'll eventually end up with the wrong answer because one of the decimals will be messed up. So I try and convince you to stay with logs as far as you can to the very end so that you don't make that error. Okay? Any others on this? Because I'm going to show you the opposite right now. So this is when you have exponents that you need to move to the front. So you take the log of both sides. So question 7 is when you have logs and you want to change them to exponential. I'm going to go right to D actually. I'll do that one with you. So I'm going to switch D right off the hop here, just so that I have the logs on the same side of the equation. Okay, does everybody follow what I did there? You guys all follow that? I just moved the log over and the 3 to the other side. Okay, so at this point, in order to solve for the x's that are in here, I need to change this to exponential now. So the first thing I do is I have to change it to a single logarithm. How is this going to look as a single logarithm?
Is that 4x negative 6 over 2x negative 5?
Very good. On. Just like that, right? Log rule number 2, when you have subtract, that means divide.
Where are all these log rules?
Equals 3. In your book.
Equal to
On your identity sheet too.
Okay, how do I change this to exponential?
5, 3 equal that.
Yeah. So I have 4x minus 6 over 2x minus 3 is equal to 5 cubed. Okay? 4x minus 6 equals 2x minus 3 times 125. X minus 6 is equal to 250x minus 375. 269 equals 246x. X equals.
I have 1.5.
You have what?
1.5.
That seems a little high. 269 divided by 246?
I got 1.09.
Yeah, that sounds more like it. Always 3 decimal places.
093.
Yeah, sorry.
You have to give this section is one of the rare sections that they'll very specifically ask for 3 decimal places on the exam. Okay? Check that again on. Okay. 246. No, sorry, 269 divided by 246. You went 246 divided by 269. Yes? Okay, so back to this. You have multiple logs, put them on the same side. Change it to one single logarithm. Change it to exponential. So step 1, take the logs to one side. Step 2, use your log laws. Step 3, change to exponential. And then step 4 is basically the start of your solving process. Lots of times you'll end up with a quadratic there, so you have to get it equal to 0 and solve by factoring. Okay? Those are the 2 primary questions in this section that get asked on the exam. They are on every single exam. Yes, Jeffrey?
Okay, where's the 269 from?
Oh, it should have been 369.
Yeah, that's what I had.
Yeah, my bad.
was confused.
Thanks, Jeffrey.
It should be one.
That's probably why you ended up with 1.5, is it?
Yeah.
Should have been 369.
Yeah, that's
So
what I got.
369 divided by 246. What is it?
1.5.
3 decimal places.
It's just
1.5.
1.5.
0.
So we need to put 0, 0 there. Now you gotta remember that. If it asks for 3 decimal places, you need to have 3 decimals. So make sure you read the directions closely. Okay? Alright. Any questions about that guy? So 6 and 7. Number 4 deals with 3, 4, 6, and 7. They basically all deal with the same things. Okay, they're all done. All those questions are the same on there. 3, 4, 6, and 7 on page 288, 289. And those are what we have to focus primarily on. Number 8 as well. So that's that. So you're going to get to the end of the week here to finish off chapter 7 and 8. So you got the next 3 days to do that. 2 days anyways, for Wednesday. Okay? Test right now is set for Friday. It may move to, well, let's set the test for Thursday, but it could end up on Friday. We'll see where we're at. I know you're away Friday, so be prepared to write Thursday.
I wasn't here when you got 8.3.
No, you weren't, because you were away Friday.
Mhm.
So, 8.3. Videos posted. What's 8.3?
Logarithm.
Is that your log laws? Yep. No, that's what that's 8.4. That's 8.3. No, just using your log laws, so look at page 275. You did this and applied it already. So you're converting from a single logarithm to multiple logarithms, or you're taking multiple logarithms and converting it to a single just using your laws.
Okay.
Alright?
I don't remember doing this in a
Okay, then watch the video from Friday. It's posted. You can do that right now. Do you want to watch that? Like I can show you, I'll show you 275 question A. So you've got log base 4. X squared y 4z. Okay? X cubed. Same thing in A. Okay. Anything on top is multiply, which you add. Anything on the bottom you have to subtract. So this changes to log x cubed to the base 4 plus log y to the base 4 minus the log of 4 to the base 4 subtract log z to the base 4. Okay? If it's on top, you're adding them. If it's being divided by, you subtract them. Follow? So the first law, look at the product rule. The log of m times n changes to the log of m to the base c plus the log of n to the base c. Quotient, log of m divided by n, is log m minus log n. Power, move the power to the front. So I got to do that yet. So I got to take this, move it to here. 3 log x base 4 plus the log of y to the base 4 minus. What's the log of 4 to the base 4? 1. It's another one of our rules. Subtract log z to the base 4. Yeah.
How come you only need 1 3 over? Why didn't you do it throughout the whole thing? Like
There's no other exponents. This is an exponent.
Okay.
It only moves exponents to the front.
And then when you do 4 log 4, that's 1.
That's equal to, the log of any number to the same base is equal to 1. Yes. Okay?
How come,
Sorry, it's my bad.
How come when you subtract the log 4 base 4, like at
Because
that
it's
first
being
step?
divided here.
I know, but when it's divided, it doesn't say that's right before it. It just divides. I mean, it just says m subtract n. How do I know that I have to subtract that whole equation from what I already have?
It's all on the bottom of a fraction. So you subtract anything on the bottom of the fraction.
Oh, okay.
And you could do it like this. Try not to confuse you, but it will.
Yeah.
But then you have to distribute the negative through, so I end up with this anyways. I don't show you this because you'll mess this up. I show you by just taking each individual piece and adding or subtracting it. We don't do much of this. We don't do much going from here, from there to there. We do a lot going from here to there, to a single logarithm, which is the second part of that. Okay?
so then is this one of the units that will be used or calculated on this thing?
Yes. Yes. The one question on log